It's noon. Have an hour before lunch. Great to have big audience. You guys are really, either you really want to learn about Intl extension or you really don't want to go to the algorithm review talk. Repeat your computer science from school. So this is a little bit of an evolution. I gave a talk on internationalization in the past, and it mentioned this Intl extension. I decided just to take that portion, expand it, because there's a whole load of new stuff that's been added to Intl since that time. So I believe that slide transitions are a dangerously depleted resource, so this will be the only one you see in this presentation. Right. Just a little bit, some little facts about me. I'm software architect at AppDynamics. You may not have heard our name, but our software helps a lot of very well-known companies keep their applications running in top form and provide operational and business intelligence. We support Java, .NET, PHP, Node.js, Python soon. And at the very high level, once you drop our agent in there, it automatically maps out your application flow, all the different services it's accessing, provides stats on that, deep dive instrumentation in case things go wrong. And if you want to learn more about this, I'll be hanging out. I can show you a demo. I was a PHP core contributor. I say was because I'm not anymore, despite what people may think. I did it for a decade and decided I had enough. And the reason I had enough mostly is because I was the architect of the Unicode and Internationalization project in what was supposed to be PHP 6. And I'm probably the reason why there won't be PHP 6. I'll just jump straight to 7. Because some people prematurely published books and things like that on PHP 6 that had to be then pulled off the shelves when they decided that Unicode wasn't going to happen in PHP. I'm also at A on Twitter. Don't try to reply to me. I probably won't see it. If you saw my talk last year about, it's worse since then. I also like beer, both the drinking and brewing it, so talk to me about that too. Good news, everyone. Unicode 7 was released recently. In case you didn't know, there's a whole lot of new characters that have been added. My favorite 3 are these. Yes. I just want to see when the committee sits down and they try to come up with names for these. Like, oh, Vulcan. So raise hand with part between middle and ring fingers. Okay. All right. So some terms, they get thrown around like internationalization or I-18N and localization. What do they really mean? Well, internationalization means you develop your application in such a way that it doesn't have any built-in assumptions. And it's also in the way that it's efficient to localize. And localization comes after that, which is where you take an application like that and then tailor it to meet the needs of a particular culture or market or group of users. So you shouldn't have any assumptions, like English, French, Chinese, Indian, whatever, Russian is just another language. There should be no preference for a particular language. Your country is just another country, Earth is just another planet at some point. So keep that in mind. Now, why would you want to localize and do all that stuff that you probably don't want to do? What are we looking at here? All right, so you're looking at about 2.5 billion combined population between China and India, not to mention part of Russia there as well. The whole BRIC countries, you've heard of them, right? Brazil, Russia, India, China. It's going to be huge in the next decade or so. And English speakers are a minority now on the web. And surprise, surprise, when surveyed by this awesomely named Common Sense Advisory, people said, oh, I'd prefer to buy from sites in the languages that I speak or understand. So global customers will pay more for products with information in their language. So another term that comes around a lot is locale. And what is locale? Well, for purposes of this talk, it's basically an identifier that refers to preferences, both linguistic and cultural, of a certain user community. And in the types of locale that Intl uses, there are 5 different portions in the identifiers. There's language, script, country, variant, and keywords. And everything but language can be optional. And it can be as simple as something like English in Great Britain to this, where it's like Serbian, which is in Latin script, because it can be in Cyrillic, from Yugoslavia, revised orthography, and currency US dollars, right? But we'll use simpler ones. Now, in order to have good localization, you need good locale data. And you really don't want to do it on your own. So there's this awesome project called Common Locale Data Repository, which is run by Unicode Consortium. And they do regular releases. They gather all this locale data, they proof it, they test it, and then give it to you to use. Latest count, I think they have 740 locales, 238 languages, 259 territories. So we're here to talk about the Intl extension that's basically been available since PHP 5.3. And it's both in PECL and I think maybe bundled with PHP now too. If you haven't had a chance to install it, it's really easy. It does rely on the external library called ICU, which you'll need to install via whatever package management system you use or build from source. But it provides a whole bunch of things for you that you can use in your applications. Things like formatters and parsers for numbers and messages, sorting, character set conversion, transliteration and text transforms, boundaries, calendars, time zones, and we'll talk about some of these. Now, the API for the Intl extension has both object-oriented and procedural. I can decide if it's for people who can't come with the grips that PHP has had object-oriented support since, what, version 4, right, or whatever. Or it's just to provide fodder to those who rant about PHP having more than 2 ways to do everything, right? But it's pretty simple. Like if you prefer to use the procedural as collate or create, equivalent to extension class, same thing here. You can figure it out. In my slides, I use object-oriented format. So let's jump into this. So one of the new things that got added to the Intl extension recently is this thing called UConverter. Unfortunately named just because that's the name of the class in the ICU library. Could have been called differently, but oh well. And the purpose of it is provide robust conversion capabilities between various character encodings. It's basically a replacement for MB convert encoding, which is a fine function, but this gives you some additional things that you can do with it, plus access to all that awesome character and locale data to start with. It has both like simple API if you just want to fire off and do one conversion, or if you're object-oriented if you want to instantiate an object and then do things more than one string. So for example, we can say you convert a transcode and you give it the string to transcode here. This is the target encoding. This is the source one. So here we're going from Latin 1 basically to UTF-8. This is the Cedilla character. And echo it out and you come up with the result. You can go backwards from UTF-8 to Latin 1. And if it can't map a certain character into the target encoding, this is not Latin 1. This is, I think this is the Hebrew one in ISO. And like I said, I apologize. It's really hard to see the bottom of the slides in the back, right? But they'll be online, so you can sort of run through them later. And if the Intl extension can't map the character into the target encoding, it replaces it by default with hex value 1A, which is Control-Z or whatever you want to call it. It's a non-printable character, which is why it doesn't display here. But you can customize that. If you want to, replace it with a multiplication sign or something like that, then you can provide an optional parameter here saying, when you do the conversion, they substitute the character with this, and then it comes out like that. You can put a snowman in there if you want, if that's supported in the target one. Oh, what? Yeah. Now, so far, this is pretty close to what MB convert encoding gives you, but it's way more customizable because what you can do is extend the class and override these callback functions that will be invoked when it needs to map a character to something. And it looks like this where you say extend the class, and then there's a function called from U callback, which happens when you convert from Unicode to something, from UTF-8 to something. And what we can do here is that, okay, let's say we want to translate the square root sign to some text instead of just a single character or omit it or whatever. So we can say if reason is unassigned and the code point is this, which is the square root, reset the error to 0 because otherwise it'll error out, and then return the replacement. And then when you convert from UTF-8 to ASCII here, it comes out as, it'll come out as what is square root of 2. I forgot to put the output there. Sorry about that. All right. Any questions about character set conversion? And if you do, raise your hand so that the microphone, okay, yes.
I wonder if there is any method, class, or function to convert a string, UTF string to an array of code points, like something low level, so we can interact with it.
You can, I don't think there's anything built in. You can convert to UTF-32 encoding, which is sort of like that, because it gives you full code points, but it'll still be in a string representation, right? So I don't think there's anything built in, but there could be.
No, because I did it and it's very slow if you do it now.
Yeah.
Processing every single byte. And
I agree.
was thinking maybe there is something
Not to my knowledge. I don't think this one has it.
Thank you.
So next thing is collator class. And collation is another term for ordering or sorting. As you can imagine, different languages have very different rules about not only like what order the characters occur and what order they should be sorted in, but they may sort more than one way depending on what the target text will be used for. For example, in German, whether if you're making a dictionary or a phone book, they're going to be sorted different ways. Or in Spanish, traditional versus modern Spanish sort differently. Or in Japanese, you can start with stroke and then radical sort, or vice versa. So the primary thing to understand about collation is that it has this thing called levels. And there are 5 of them. And they proceed from primary to down one to the identical. Primary basically means distinguishing base characters. Secondary is accents and some language-specific differences. Tertiary is so uppercase, lowercase, and some variants of base forms of base characters. Quaternary, you'll never use this. There's no need to know about it. And then identical is trust me, you won't. Identical is a tiebreaker. In case it's gone through all of them and it still needs to compare them, then it'll do it on that level. And these are also called strength for some reason. And each locale has a default level setting. So for, let's say if it's English, then it's only going to be base characters normally, maybe with accents. And in Japanese, it's going to go down to the 3rd level or 4th level. And the differences in lower levels are ignored if the upper ones compare characters as different. So using it is pretty simple. Let's say we want to compare 2 words in French, which look very, very similar, but you need to know what order they come in. So you can say instantiate the collator for the French language in France, because you can do it for Canada as well. And then you just say compare, give it 2 of them, and it returns just like strcomp -1, 0, 1. And echo it out. And it's going to say that first word happens before the second one, before cote. Strength control. So let's say you want to ignore the differences in accents. You just want to compare the base characters. You just set the strength to primary, and then call compare. And if it comes back with a 0, they're the same, which in this case it would be. So aside from comparing, it has a couple of sort methods. So you can pass it an array of strings, and depending on what settings you also provide, it'll sort them appropriately. So for example, these are all different words, right? And we want to know what order they should be sorted in. Now the trick here that in French, when you sort things, when you compare words that have accents, ones that have accents at the end get sorted to the bottom, even though otherwise they wouldn't be. So, but you don't need to worry about it because you just instantiate the collator and say sort, and it comes up with them in correct order here. You see the accents one here at the bottom, which you would never know otherwise unless you're particularly interested in that. So some other things you can do, you can set different attributes. You can say, for example, I want to sort uppercase first, because usually it's lowercase, right? Like at least in ASCII, lowercase comes first. You can say case upper first, and then when you compare ABC and ABC, it's going to say it counts them before the lowercase version. The next thing is numeric collation, which is very useful if you, yes?
What means case first? Can you repeat that?
What means case first in there?
Case first is the name of the attribute. So it says which case should come first, and the value is upper first. So it says upper characters should be, it's not the best naming, but. So the other thing is numeric collation, which if you're around this where you are trying to sort like numbers and like 10, 1, and 2, and it puts them in the wrong order, right? You can set numeric collation to on, and it will sort them like numbers instead of, in numeric order basically, instead of in the string length and all that stuff. Any more questions on collation? Yeah, you're gonna work today.
I can see that you switch the numeric collation on here, and I assume you have to switch it off again. So is there a method to ask the collator what are all your settings at the current moment?
You can get, there's get attribute, so you can say get value for numeric collation, and yeah. I'm not going through all the different methods, just highlighting certain portions. So the documentation for the Intl extension, some classes are well documented, as some are sort of very skeleton level, which is, at the end I'll give a couple links to the ICU project, which if you read through that, it'll have more information about what collation actually does and what are various things it can do and things like that. Number formatter. So this is basically a class to use when you want to format numbers in a locale sensitive manner, or given a string that represents a number, parse it into an integer or double, depending on the locale. And it's a replacement for number format. And number formatter has a variety of different styles that the number can be formatted in. And I'll give you an example of, I think, most of them. So let's say we want to take this number here, 1234.567 in French locale, right? And these are the various styles you can format the number at. There's a pattern decimal, which depending on the pattern you pass it, formatting pattern, it'll do different things. But then, and it's the most customizable one, but then there's a built-in decimal, I just want a number, and it'll format it appropriately. Or if you say I want a currency, then it'll format it as a currency with a currency symbol included, which is useful. Because there are rules for currency and symbols, the way they appear before, after, if they're expanded in full, like what the actual symbols are all different. Another one is percentage, because clearly decimal and percentage are very different here, and it'll format it appropriately. Another one is scientific notation. Spell out is very cool. They just spell out the number for you, in case you're learning language or whatever. Ordinal is the things like first, second, fourth, and so on, with appropriate suffix or prefix or whatever else the language has. And duration treats it as a segment of time. So even in US, like here, it just gives you this number rounded up. In US, it actually gives you like hours, minutes, seconds, with the dots between, with the colons between them for the English locale. It's really easy to use. You just instantiate a formatter for the locale that you need and the style, and just say format, and boom, it comes out there. Another method that it has is called format currency, and it's slightly different than just instantiating the currency style, because you may want to have the formatter for a certain locale, but format currency for another country, right? Otherwise, it'll treat it as a local currency in that locale. So in this case, we have a German Swiss locale, and we say format currency, but use the currency code for Chinese RMB or yuan, right? And it comes up with the right representation of that. So that's format currency. And you can go in the opposite direction. You can parse a string into a number. So in this case, we want to take a representation, let's say, of an integer in Indian locale and a decimal, and parse it into an integer as well. By default, it's a float for some reason. So you just call parse on this, and it comes up with the result. And if it can't parse it, it gives you false. So you can act on that. Any questions about number formatter? One there.
I wonder if the parsing understand also the numbers written in other languages like Arabic numbers?
Yes.
Or just...
yes,
okay.
it will.
Thank you.
All right, so from number formatter to message formatter. This is actually really important and very useful. And what it does is it produces concatenated messages in a language-neutral form, language-neutral manner. I'll give you an example on the next slide, but it basically operates on patterns, so like formatting patterns that could contain subformats. And the thing about this is that the program does not need to know the order of the fragments. So the program just says, I want to format this message, and these are the arguments, and then it's up to the localized representation of that message to select the right number from the arguments, right? So typically, let's say we wanted to format, today is February 22nd, 2014, that string. So in PHP, the old way, you probably do something like this. Echo today is, and then call date or stirf time with appropriate formatting, which is fine. But then you run into difficulties when you try to localize this, because you need to know the right place to splice this into, and also what the right locale representation is and all that stuff, right? And with message format, you give it a pattern where you say, today is, and then this is the argument number, so 0, first argument. And this is the type that it should format it as. And the other portion that goes with this is the argument. It's an array of parameters. So here we just pass the current time, and then it produced this. So here's another example. Let's say our pattern is on 0th argument date, you will have 1 number meetings, right? And we pass it 2 arguments. We instantiate it for the English US locale with this pattern, and we just say format it with these arguments, and it produces this string for you. Clear so far? Here's a little more complicated example. In addition to just the type of the argument, you can also provide some hints as to how it should be how that type should be formatted. So here we say, okay, I want a date, but I want a short representation in that locale rather than the full one. And I also want this number treated as a currency rather than just an integer. And then when you pass this in, and let's say we use a English in Great Britain locale here, it'll format it appropriately, which is very cool. Yes? Hold on.
So how did you make a different pattern for different languages then?
Yes, and I'll talk about the need to do that later and how you would go about doing that too. So here's a French example, right? And like I said, depending on the language, the location of these where the things should be formatted into, the parameters will vary. And here we say, okay, we'll select the second one here, sorry, the third one here, I guess, then the first one, then the second at the end. And we want to format it as a date, and you can give date formats here. Like, I only care about the date, the day and month, and so on. And then we pass it this array of arguments, and the pattern appropriate selects the one that it needs from that list of arguments, right? And then French locale formatted, and here's your locale sensitive message that it generated. which some of you can't see, I realize. All right. And you can also parse messages. So let's say you have the same pattern as before, and then you have the text that we generated, or you received it from somewhere or whatever. If you just say parse, and I realize they should say text instead of arguments, so I'll have to fix that. Then it'll give you back an array with the timestamp, which is what it parsed this date into, and the number that it parsed from there as well. So this is really cool too. And the patterns are, depending on how deep you want to go in, can get really complicated. Some languages have different pluralities, right? Depending on whether you use 0, 1, 2, whatever, the things you want to put into the message may change, but you don't know ahead of time what the argument will be, right? So you can put in the rules in the pattern itself saying how to handle that. So here we just want to say, something like, if you did a search for something, there are X results or no results or whatever, right? So you do something like this where you say, okay, this is going to be a plural selection, and when it's 0, produce this string. When it's 1, say produce this string, and the hash gets replaced with the actual argument that it received. And otherwise, if it's more than 1, then produce this string. And then we instantiate it for the British locale, and then format a couple of times, and here's the result, which is really awesome, I think. And it has other things for like gender selection and choices, which is, there's a whole lot of stuff. And none of this is documented in the Intl extension, but it is documented in the ICU user guide, which you can take a look at. All right, break iterators. So these things let you locate linguistic boundaries between various units. And the units that it operates on are characters, words, lines, and sentences. Characters are basically boundaries between what we usually think as characters when we look at a text. So what they also call graphemes, because underneath they may be represented by more than one code point. The word boundaries are for things like if you're doing a word processor, you want to double click and select a word, where should it actually do the selection? Lines is where you could put a line break for wrapping text, and sentences just, for a larger unit that represents the text. And you can do more complex ones with custom rules, which I'm not going to show here, but all these are built on those rules for each locale. So as an example, let's say we take this sentence, right, where we have a number of different punctuations. We have question mark embedded here. We have another period here, and this is the actual end of the sentence. Like doing it by hand or by any sort of like logic you want to write yourself would be pretty hard, I think, right? But you say Intl Breakit array create sentence instance for the locale that you want, in this case English. You set the text, and then you call this thing called get parts iterator, which just gives you the actual parts of the words. Otherwise, it has methods to access the boundaries. But in this case, we want the actual words, not the boundaries. The units, not the boundaries. And then it produces the correct sentences instead of potentially splitting on periods that there's like 5 of them there or 4. But if we wanted to figure out where we can wrap this text, if we're doing it on a line-by-line basis, then we can instantiate a line iterator, and then the result will be basically where we can put a line break in. So that's one usage of it. Another is if you it also acts as a boundary interface. So you can say, okay, take the same line break iterator and rewind it to the beginning, so the very first boundary, and then give me the next one. And each time you call next, it advances to the next boundary. So in this case, it keeps progressively outputting. We keep doing larger substrings. Or you can say, what's the boundary preceding this offset here? And it'll give you the boundary before that. So it's got a number of methods for like working with boundaries in addition to the actual units. Any questions on this? Yes.
I wonder if the boundary method also works with Chinese.
Absolutely.
So it does the Chinese chunking.
Yes.
It detects the single word.
Yes.
Okay. And this is available right now.
It's available right now.
That's a good news. Yeah.
I just made your day, didn't I?
No, because
Just kidding.
I was working with this type of problems, and I saw that it's quite complicated, especially Chinese. There are various methods and things.
Sure. And I'm not going to claim that it's perfect, but
Okay.
it's better than
nothing.
Yeah, nothing exactly.
Okay, thank you.
I haven't personally tried it, but the Locale data that this operates on, I mean, they ensure that it produces the correct results, and there's always updates. So it may, if you can submit bug reports against this too, and they'll fix it in the next release. All right. So resource bundles. This goes to your question about how to localize for example, the message formats for various languages. So resource bundles contain resources that you want to localize. So things like strings, various messages, formatting patterns, numbers, all kinds of stuff that you want to access them in a locale independent fashion, but have this data localized for each locale. And resource bundles let you do that via you can produce a hierarchy of your data. And what it does, and I'll mention fallback in a bit. So let's say you want to organize your data in a fashion like this, right? You pretty much always start at the root, which contains your unlocalized or untranslated resources. And then you can break it down by language and say, okay, we're working in Spanish, English, Japanese, and Chinese. And then another level could be that Chinese has simplified and traditional representations. So we can split it on that. And then past that is a country level. So here we have English to US, Spanish could be for Spain or Mexico, and then here you could have China using simplified and Hong Kong using traditional. And the key thing here is a thing called fallback mechanism, which means that if you request a locale that it doesn't have, then it's going to fall back onto the one operating the hierarchy. Or if you request a resource in a locale that it doesn't have, then it is going to look up the hierarchy again. So if you try to request for example, this locale here, but let's say we didn't have it, then it would look here first, then here second, and then finally in the root one. And the data format for how you construct these bundles, it's just text. You make text files basically, and you can have simple resources, which are things like strings, integers, binary data if you want to embed images in there, or integer arrays. And complex resources are basically arrays and maps, arrays and tables. So let's say we want to build up a simple resource bundle. So we'll start with the root one, where the unlocalized ones are. And I'm grossly simplifying here, but let's say we have this root.txt file. This is the name of our locale. We'll put a string in there, like for version. We'll have a main title. Let's say, welcome to our store. You can have an array of strings. Here we have some like website being this is maximum, and this is a formatting pattern, right? So you can see how when you localize this later, you can switch things around and translate it and omit some things and select which argument you want to use. And this is a int vector, array of integers basically. And let's say we have another locale for Great Britain. And here we yeah, I struggle with what to put in there. But here, notice we override only certain ones. We override version, title, and sizes, and we leave the errors the same. So in this case, if you request errors from this locale, it'll actually go back to the root one and find it there, right? So once you localize your messages and data in these files, then you need to compile them. And there's a tool that comes with ICU called genrb. So you do something like this, where you say, make a directory, and then genrb, put the resources here, and give it the list of these files, right? And then when it runs through that, it's going to tell you, very terse message saying how many files it processed, and it's going to generate these binary things that you can load up later from PHP. And so let's say we want to retrieve this. Let's say we just want to do a root one. So we find where our resource bundle directory is, and we say create for the root locale. This is the directory. And then it gives you back an object that you can access as an array, basically. You can say main title, give me the second error, what are the sizes, and it gives you this stuff, right? And let's say we want to retrieve the Great Britain one. So we just switch out the locale, exact same code after that, and then it gives you the appropriate thing that it found. Yes?
Yeah, I had a question about the format of the text files, because it wasn't clear if you're using just a custom format or...
It's ICU custom format that they came up with. Yeah.
Is it documented somewhere?
It's
or?
documented in the user guide.
All right, yeah, thank you.
Yeah, pretty well, actually. So you can just refer to that.
All right.
So that's the basic idea. Let's say we request a locale that doesn't exist at all, right? Like German, we didn't localize for that. Then it's going to use the root one, because that's the one that happens right before in the hierarchy. So that's it for resource bundles. All right, next thing, spoof checking. It's pretty awesome. So Unicode has like a stupidly large number of characters, right? And has a bunch of writing systems and scripts. And if used incorrectly, you can run into some security holes or security problems where malicious people can do things like this. You ever see this? Guess what happens when you click on that? It does not go to PayPal. Because in fact, this is not an L, this is an uppercase I. And this was actually an exploit that went around, and naive people, clicked on it and said, hey, log in into my PayPal account, I want my money. And they stole their passwords. So Spoof Checker helps you deal with things like this. It helps you prevent certain classes of security attacks where which rely on sort of visual confusion, which can be pretty pervasive, because used to be that they may have had a confusing URL in the body, like in the browser, but if you moused over it, then like you could see the real one at the bottom of the browser. But with JavaScript and all that stuff, all that's like already been defeated. Though in the real way, people thought, all right, I actually load it up and see what's in the URL, right? Well, guess what? Because of internationalized domain names, you can have characters from other languages and domains now, which are visually confusing, right? And you're screwed. Don't ever click on a link. This lets you check identifiers for visual confusion. And it's various types of confusion that can happen. You can have two identifiers from the same script, but are confusing, like that PayPal, L and uppercase I. You can have two identifiers that incorporate characters from different scripts and confusing. And you can have identifiers that one is from one script completely and one is from another, but they're still confusing, right? So here's an example. You say, we have two URLs, right? We have Google and Goog1e. And if we say new spoof checker and we say, are they confusable? It's going to say they're confusable, right? Which is good. Now here's another example. This is for the single script. Now for the mixed script. What do you think about this? Are they confusable? So the second O is a Cyrillic O. And I had to go through a few fonts where they would not be distinguishable. Otherwise, depending on the font rendering, you may notice the difference. Like here. So this is a method called confusable. There's another one called is suspicious, which just tells you whether a certain identifier is suspicious on a certain locale. So let's say we have this here, which does not say hope, by the way. It uses Cyrillic letters to pretend it says hope. Where you say, okay, we're only allowing English locale here. Is it suspicious? And I say, yep, it's suspicious in that locale, because it's using characters from another one. But if you say, oh, allow Russian one as well, then it's going to say not suspicious, right? So that's useful. Now, my favorite section. So transliterator is a thing that you can use to do script transliteration, which is converting or representing characters from one script in another in a way that sounds the same, basically. You run into it all the time when you transcribe foreign names, for example, into English or vice versa. And originally it was used just for this, just for script transliteration, but it actually is a much more general transform mechanism that is very customizable, and you can do things like case mappings, normalization. If you're familiar with Unicode, you know what normalization is. Full half-width for Japanese, like convert code points to hex or character names and things like that. And the basic thing that it works with, and transforms can be chained together to perform a series of operations, so it's not just a one-trick pony. And the basic idea is it uses this thing called transliteration IDs, where the format is something like source, from where you're going, to target / variant. And source and target specifiers can be script IDs, like Latin, for example, or katakana, or Greek, or it can be Unicode language identifiers, just the short ones like FR, EN, or special tags like any or hex, and I'll show you an example. The only really required one is the target, because if you don't use the source, it assumes it's any, and if there's a rule in there that it can understand from the text what the script is, it'll just use that. And variant is just a modification on some conversions. You can create inverse if you swap target and source, or you can call create inverse method to just do it automatically for you. But keep in mind that not all transformations are reversible, right? Like if you do lowercase something, you can't really restore it back because you don't know what the original was, right? Somewhat lossy. So here's an example. For some sample IDs, like I want to go from katakana to Latin, or I want to go from Latin to ASCII. NFD is normalized decomposed form for Unicode. Or I want to go from any to hex, but basically take characters and represent them as hex entities in XML format. So script conversion. Let's say you say, all right, I want to go from any to Latin. Here's the sign that I saw in Japan somewhere, right? And transliterate it, and it says it's Makudo Naruto, which is what McDonald's is. And we can check. We can say, okay, create a Latin to katakana one and transliterate it back and make sure that it matches, because katakana to Latin is reversible. Here's another example for Cyrillic. So let's say I'm going to go from Cyrillic to Latin. Here's a Cyrillic thing, and it produces something like this, which I'm Russian. Like the way I'm used to transliterating is not like this. There's a different format, and you can use that format if you use a variant /BGN, which is like Board of Geographic Names or something like that. And if you transliterate the exact same phrase, it's going to give you something like this, which is, I think, more pronounceable for foreign speakers of Russian. All right, let's say you want to get, if you use any to name, it gives you back the Unicode character names for the symbols. So here we have Cyrillic small letter Ya, and then $, just as an example, in case that's useful for you, in case you want to know what the actual Unicode symbol is called. There's a useful one called Latin to ASCII. So it tries to take the characters and represent them in ASCII as close as possible. So like you give it a copyright sign, it actually produces 3 characters that represent copyright and things like that. Compound IDs. So let's say we have Greek to Latin, and we give this Greek phrase to it, and it gives us back the result. But we don't really want accents. Accents are confusing. We just want base characters, right? So there's a way to do that, even though it's not built into this transformer. But we can say something like this, right? We can say create, so Greek to Latin first, then decompose it into base character and combining ones, the accents. And then this is a filter. It says for any non-spacing mark, which are the accents, remove them, get rid of them, and then compose it back into one character. And when it runs through this, it gives you back the result here. And there are various filters and rules, mappings you can use. You can say like, okay, take only certain characters that match this filter in lowercase and uppercase and whatever, or translate only those. And if that's not enough, there's rule-based transforms. So you can completely write like in another language that I guess they invented, sort of like regular expressions. Maybe they didn't need to do that, but there's rule-based transforms. So let's say we want to write a rule which collapses multiple spaces into a single and converts those fake dashes, dash into real ones, right? So we say create a variable $space here, and then this is a syntax that says if you see this, convert it to single space. And then, or if you see this occurrence of sequence, convert it to real dash, and the less than greater, that means it goes backwards as well. So if it sees a real dash, if you do the inverse one, then it'll go back to 2 dashes, which is good. And then you say create from rules and give it this very spacey and delimited remark, and it gives you back the result, right? Which is pretty cool. So we could talk a whole lot more about there's things like which I wanted to put in, but I felt it would take too much time. There's classes that deal with date times, time zones, and calendars, which have a huge number of methods. And if you're really into that, I encourage you to go look at that. But for now, so the PECL is where the extension lives, where the updates are released. The php.net/Intl has the class documentation, and some of those classes, like I said, are better documented than others. cldr.unicode.org is the common locale data repository one. So you can go and see when they did the latest release or what they fixed in it in case there was a problem. And this is the user guide for the ICU project, which has more documentation, as I mentioned. Questions?
Are you familiar with the framework Symfony 2?
I've heard of it.
Yeah, they do translation differently. Is there
I actually have no idea what they use. Somebody know?
okay.
Yeah, somebody does know. They got their own built-in, I guess. Yeah. Anybody else?
Hello. Right at the beginning, we were talking about what character sets you can convert between.
Mm-hmm.
I'd like to know if you can convert between UTF-8 and, say, GSM characters that you can send via text message.
Can you convert between UTF-8 and UTF-7?
I think it's a subset of UTF-7, isn't it?
Is that your question, though?
Well, my question is, of all the characters you've got in the GSM set, I think there's only 128 or something like that in the standard one.
What's going to happen is that if the converter can't map the character to the target character set, it's going to use that substitution one, whatever is defined by default, which is usually that the control Z, not the non-printable one. But you can have a custom one for your target character set.
Okay, thank you.
Just a tiny one. Can you use named arguments in the message format rather than numerical?
I think you can. I haven't actually tried it, but I think they do have a named argument support. There's one there.
With the word boundaries and all that kind of splitting into words and sentences, is there any data on how performant that is? Because obviously there are very naive kind of algorithms of doing it, and they're going to be a lot faster. But
I can't speak to how performant they are, but the same rules that the boundary analysis is based on, the CLDR data, is used by Apple, a bunch of other companies like that. So I'm pretty sure they put in effort to make them as performant as possible.
Right.
ICU library, like the ICU library is used in Java as the basic, like it's been bundled with it forever.
Okay, cool. Thank you.
Yeah. In case there's no more questions, thank you. Yes, one more.
I was just wondering if there's some sort of support for the way the characters are stored in a database. Because in the past there's been some conflicts about the database collation and getting them out and getting different characters back, and that's kind of difficult in many situations.
Yes, we will not mention the database name. that has terrible support for it. It starts with my and it ends with SQL.
Yeah.
I would only say if you want to store something in a database, make sure that the database tables or whatever collections in Mongo, like they are UTF-8 and you store data UTF-8. Like beyond that, this has no particular support for any databases.
Okay.
Yeah. It's a general tool. It's not specific for a certain database format of system. There's a joined in link there, which you probably can't see, but it's 10704 is the talk ID, or you can just go to joined in and find this talk. I would appreciate comments if you have any. Otherwise, let's go eat.